Hello everybody, this is Hardcore75 and today I'm going to record a new video about Dream POA bot. In this case it's going to be a video about Visual Studio setup, and I'm going to show you how to create Visual Studio project to create your content for DPB, or in this case to modify some existing content. What we will do today is loading the existing example routine and modify it to add functionality for Blade Vortex. It's been a request from a customer, and so I will take the chance to show you how to do it. The first thing that I want to mention is that I use Visual Studio 2022 because it solved a really annoying bug in WPF project. I really highly advise you to do the same. Download the community version of Visual Studio, and it's going to be a really fun and enjoyable experience. So let's get started. First thing that you want to do is create a new project, and to create content for DPB you need to select this one, class library.net framework. Click next. Then you need to select a name for your project, and in this case it's going to be example routine underscore Blade Vortex mode. This is the location where the project is going to be created, the name of the solution, and make sure that you select Net Framework 4.8. It's the one standard used by DPB, and click Create. And in a few seconds Visual Studio will create your project. The first thing that I want to say is that since we are going to import some existing code, we don't need this file, class 1. So I'm going to delete it. Then we need to add references to Dream POA bot executable file and a couple of other DLL we are going to use, and also some standard Microsoft API. Let's do it. To do it, you just right click on references, add references, and then you browse your DPB folder. And the file that we need as base file are this one, the Dream POA bot.exe. That is the base, the main API. We are going to need log4net for logging purpose, and lastly we're going to need Newton.json DLL to set up the settings. We just select them all and click Add. You will see them are already selected, and click OK. Then we will need some basic references to Microsoft API. So we head again, and we go to Assembly and Search. Okay, we are going to need 4 of them. They are form to easily search them, they use the search feature, and we need this one, system window form. Then we will need ExampleRoutine and this one, system exam. So select it. Next we are going to use these two, presentation core and presentation framework, and we had them, and that should be it. Okay, this one also, it's really commonly used, so I highly advise you to reference it. Window base, and then click OK. That should be it. Now I want to import the file from the example routine that come from the standard zip file, and so we are going to open the folder where we have Dream POA bot, open third-party folder, example routine, and here we have a bunch of files. You need to know that there are 3 files that you can completely ignore, and I suggest you to do, and they are always the same file. Basically they are this one, thirdparty.json, and it's a file that Dream POA bot used to compile your project. And then there is 2 files named .baml and .g.cs. These are 2 files used by the VPF interface. These are basically the VPF version of the interface compiled by the Visual Studio, and they are used to speed up the loading functionality of your user interface. You can ignore these 3 files. So we are going to select just ExampleRoutine.cs, ExampleRoutineSetting.cs, and for the user interface I'm going to select only this one, ExampleRoutine.GUI.xalm. The version ExampleRoutine.GUI.xalm.cs might contain some code in some specific case. In this specific case I know it's not containing anything, and Visual Studio is going to create it from scratch, and it's going to be okay, but it's wise to eventually check if this file contains some specific code and eventually import that file too. To import those files, I just drag and drop them on the ExampleRoutine _bv mode. And Visual Studio is going to import them. First, let's take a look at the files. The main file is this one, ExampleRoutine.cs. These contain all the logic that will be executed when the plugin is created and run. I don't want to go too much in details about it, but let me give you some information about a couple of functions. This class inherits from eRoutine, and eRoutine is an interface that implements the basic function that DPB will use to load the routine, load information about the routine, and use it. For example, we have these four string here, and they are basically the author name, description of the project, the exact name of the project, and the version. This information will be used by DPB to display the same information on the top of your setting window. For example, example routine, you see author, alcohol 75, version, and description, exactly as they are here. There are some other implementation in this interface. For example, JSON setting contain all the settings. I don't want to go too much into detail about that, but basically JSON setting take the information from the example routine setting, in this case, allow the routine logic to perform some logic based on the configured setting. The user control instead, it's exactly the setting user interface, represent all these graphics and how they are connected digitally to the settings. It's really important to exactly know what these two functions does. This function initialize, it's invoked by DPB at the moment that it compile this routine. So on the loading stage, the routine got compiled, initialized, and when it's initialized, this function is called, and this function does some initialization and setup on the routine. In the same way, the initialization will be called when DPB is closed. There are some other really important functions that we want to mention, and it's the start function. That basically is the function called when you press the start button. Every single implementation of the start function you have in your different project will be called when you click the start button. The message system is a system that we are used to send messages between different components of DPB that are actually running. For example, if you have your bot, routine, and player mover running, you can send messages between them using this message system. It's a little bit complex system, but really powerful and allow you to manipulate information and pass them between components. The stop function is similar to the start one. It's called when you click the stop button. The tick function, it's a special function that all interface implement, and it's basically a function that it's called every 30 milliseconds and is usually used to manipulate information and to store them to be later used by the main logic of your component. The main function of the routine, the one that will be invoked by the task manager in the moment in which the combat task invoke the routine, is this one, logic. While the task manager itself usually call the run function of each task. There are two different concepts, but now let's focus on the routine. What you need to know is that when your task manager invoke the combat routine and the combat routine pass control to the routine to eventually check if we have a target and if we need to engage him, it will invoke this function, the logic function. Let's take a look at it and see exactly what it does. The logic function is invoked using a logic property. And basically the logic property contains an ED, and this ED can be passed by the task that invoke the logic. In this case, we use this command, hook command, to let know the routine that we invoked its logic, because we need to know about the combat state. So, if the logic ED is equal to combat, we go on and we invoke the targeting class. and we invoke the update property of the combat targeted class. Basically, what it does is invoke the object explorer that tells us all about information about all the object around the player. The bubble size is always 210 dpi. So the update function firstly invoke the object manager and request information about each object, and then what it does is passing that list to what it's called the inclusion calculation that will produce a list of valid combat targets. And that's the first thing that we do. Let's take a look at how it looks like, because you have full control over the on-inclusion calculation. And it's this function, combat targeting on-inclusion calculation. Basically, the list received by the combat targeting, it's passed, filtered through this function. Every single entity on the list will be passed to this function. What this function does, it's cast that entity as monster, class monster. And if the cast succeed, it means that the object has the monster component, and it's a monster. So we check if the cast succeed, and if it's null, we just return false. And returning false, the combat targeting will know that this item has to be just ignored, and so it will not be added to the list of possible targets. We all go on and do a lot of filtering. Please take a look at it and try to understand what they are. For example, we have a blacklist, and we check if it's containing this monster. We have some property on the monster, for example, X active. If the monster is not active, probably it's underground, or I don't know, it's on hold, and for some reason the game don't let you interact with him. If it cannot die, it probably was worthless to attack him, and so we just ignore him. And then we have a long list of other properties. Take a look at it. But what I want to say is that at the end of this calculation, this function will tell the combat targeted if that target has to be included, and will create a list of possible targets around you. But with a list, we can't just select one single target. We need to select one single target. So when what the combat targeted does now, it's passing the result of this filtering to another filters that it's called on weight calculation. Basically, we want to do is create an ordered list of priority target, and then be able to select from that list. To do so, we pass the filtered included list on this weight calculation the same way. We pass every single entity, and with a reference with the weight. Initial weight is 0. As again, we do the monster casting to make sure that it's the real monster, and then we do some calculation on the monster. Let's take some example. Here, for example, we check if the monster has this aura, cannot die. And if it has this aura, probably he is two kind of monster. It can be a totem that has the aura, cannot die, and spread that aura to the monsters around him. That means that also those monsters will have this aura. But the only difference is that the totem that produces this aura will be able to die, and so it will not have this tag, cannot die, while all the monsters affected by the aura, they will have this property, they will have cannot die. So what this does is basically select the totem that originate the cannot die aura. And if this monster is the totem, we give him big weight, basically big priority. Then we go on. If it's not this kind of monster, if maybe it's a magic monster. If it is, we give him some little weight, and if it's rare, more weight, and if it's unique, obviously we want to target him, and so we give him a lot more weight, and so on, with a long list of other filtering. Please take a look at it and understand a little bit. And what that's produce is basically a list, a ordered list, ordered by descending by weight. So that means that the list will have the object with the higher weight at the beginning of the list, and so on. So let's get back to the targeting. So we call the update targeted, and now we have this targeting list of ordered by priority. And we go on. What we want to do now is that inform that the routine that we want to eventually disable the highlight. With highlight, it means the in-game highlight. Basically, show or not show all the object on the ground and the labels. When we are in fighting stage, we don't want any label on the way. We just want the screen to be clean. So if we get into, we just signal that eventually it has to be set. It has to be disabled. Then we take our position as a reference, and we check if we have the aura grace period. If we do, we probably won't, well, just we log it. It's nothing fancy. Eventually you might want to do something in here. Then we go on, and here is where the really nice thing happens. We select the best target. That means that we take the combat targeted targets, the list of ordered entity, and obviously just monster from it, but it always only has monsters, so it's a little bit redundant, but it's okay. And then we select the first object. First of default is meant to return the first object, or default mean that if there is no object, it will just return null. So we know that if now best target has an object inside, it's a target. It's the target with the higher priority. And if it's null, it simply doesn't have any target around us. And so we check it. If best target equal to null, that means the list is empty. So we can just go on and perform other logic. And what the combat routine does, it's try to handle shrines. That means that if we have some shrine around us, it will try to click it. And if it does, it returns logic result provided that will inform the task that invoked the logic that the logic did something. And since we did something, we are not sure if we want to do just one action per round, because this gives us the opportunity to eventually every round check if we need to do something else. We basically inform the task, the combat task, that we finished and we performed some action. This will make so that the combat task will return true, and returning true, the task manager will restart from the first task, and most probably will get again to the combat task if nothing else happened, and perform the logic again. And now, if we are in the same situation, so no monster approached, we get here again, best target equal null, and then the shrine will return false. There is no shrine around us, so it tells us it hasn't performed any action. And what we return now is basically combat logic hand that will perform some cleanup for the logic. Let's take a look. What it does is set the result as unprovided, and then basically check if we need to enable always highlight, because in case we felt in a combat situation and we disabled the highlight, now at the end of the combat logic we want to re-enable it and be able to now interact with the label, for example item on ground or stuff like that. So what it does again, it's enable always highlight, and if it return true, it means that it was disabled and it enabled it, and again it return provided. And you remember the task manager will start again from the begin, fall here again if nothing changed, call the combat logic hand, and this time we have a highlight already enabled, so this will return false, and the result will be now the first result we set it, unprovided. And returning unprovided from this logic will tell the combat task that we have not performed any action, and so we can just go on, and the task manager will proceed to the next task. But let's get back to our logic. So in the last example, best target was null, and so we didn't have any target around. But now let's make another example. Let's say that we acquired a target. If we do, then we will go on and perform some other action. Basically, we create some cached information about the target. We cache name, position. We cache the number of monsters near that target, because this way we will be able to know if we want to use an area effect skill or a single target skill. And also this information is really important as proximity shield. Proximity shield is the shield that allow you to attack and damage a monster only if you are within the proximity shield. Then we set a flag to can move. We try to handle shrine again, because if we have a target we haven't handled them here. For now, ignore this stuff, it's going to be headed now. We check if we can see the target. It's done by using the exile pattern. Basically it can raycast to the monster and see if there are some obstruction between you and the monster. Check the path distance, same idea. The exile pattern will take the long length of the path that bring you to the target. And then we check if there is some closed door between us and the target. And then we set some flag. I don't want to go too much into detail. You can just read your code and see what happened. There's going to be a lot of logic performed, but it's really simple to read it and understand what exactly happened. And also they are really well commented. What I want to do exactly here now, it's I want to add some blade vortex logic. What I decided to do is this. Basically, after we ensure that we have a target, the first thing that I want to do is ensure that I have a minimum amount of blade vortex spinning around me. So what I did, I created two settings variables, and let me show you. In the example routine settings, that is the file that contain all the settings, and by settings I mean all these settings, I created two new private variables, min BV charge, max BV charge, and those are the private version of the information. And then I expose this information to the user interface and to DPB itself and to the example routine code through these two public variables. Why I do this? Because doing so, I'm able to first set a default value for the setting and then trigger the notify property changed. Basically what happens is that every time you change this property, the notify property changed fire and notify the user interface that this property has changed and allow us to synchronize the user interface and the JSON settings. It's really important that you implement this notify property changed. So after you added this property to the JSON, to the example routine setting, I wanted to add some configuration for that. So what I did, it's basically, let me show you better. Well, you can see I added these two settings, and how I did it was this. First of all, I selected the last option to get directly to the last option line, and then I added two more row definition that basically had two more rows to the grid and allowed me to add more item. And then I added this one. Okay, a label that it's basically this one, the label with the name min BV charges. And I added this property grid row 3 that indicates that we are on the third row, and grid column 0, because as you can see here, this table has 1, 2, 3 column and a bunch number of rows. And so I need to indentate it and select where exactly I wanted to display it, and I want to display it on the column 0. And then I create a wrap panel that is basically a panel that contain some other control and list them in line, and not to be confused with the stack panel that lists them on column. So the wrap panel itself has the grid row and grid column properties. So we select grid row 3, exactly the same row we use for the label, so they are on the same line. And then grid column 1, because now this is going to be shown on the column 1. And look at this special property, grid column span. This means how many columns can it occupy. In this case, if you take a look, it occupies column 1 and column 2. And so it occupies 2 extra columns. This means that allows this control to basically extend to the 2 columns, occupy 2 columns. And at the inside the wrap panel, there is this slider, that is this slider, and text box. That represents the text box where we are going to display the actual state of the slider. Let me show you something. Basically, slider has the property name, and then, well, this is the minimum setting, some margin, and the value of the slider itself. It's bound to a configuration, and guess what? It's bound to the min BV charge, exactly the property we have in this JSON, in the example routine setting, this one. So that the value of that slider is going to be bound to this value. Every time we change the value of the slider, this value is going to be changed. And also, since we change it, it's going to notify that its property are changed. And notify property changed will broadcast a message telling all the VPF interface that this value has changed and it has to be rechecked. And so the interface will automatically update. the text box we have simply has a text property that it's bound to an element name, and the element name we bound it to is the name of the slider, and we set the path, that means the value that we want to use, to the value of this element, the state of the slider. So basically this box will always contain the actual value of the slider. Okay, I don't want to. The same thing we do for the max BV charge. Obviously we give them different name to the slider, different name to the binding, and the same text box will be bound to the name of the slider. Okay, in this case we created an interactable slider. Okay, but let's get back to the routine itself. So we now have some setting, and we want to create the logic for the blade vortex. We were left at this point. We have now a target, and we handled the shrine. We don't have any shrine around, so okay, we go on. And before to do anything else, for example, before to approach the monster, so moving, before to try to attack with some ranged skill or to do whatever we have to do, what we want to do is ensure that we are casting some spinning blade around us, because that's the way we kill them. And so what we do is this. First we check this property, blade vortex slot. But how we use this blade vortex slot, this is quite important. And this brings us back to the routine start property. As I told you, this start function, it's called when we press the bot start button. At the time the bot take control of the game and you can't change it anymore. So what I added here is basically this set skill. Basically you call this function that go through all the list of skills you have on the skill bar, filter them in case you selected some you blacklisted some skill using this one, content skill blacklist. If you added something to here, we don't want to use them. And so we take all this list of the skills we have slotted, we pass them to the blacklist skill blacklist filter, and the result will be a list of usable skills. And for each of them we check if the internal ID of that skill is this one, new blade vortex. Funny name, GGG. But yeah, that's the name of the blade vortex actual skill. And if this skill is a blade vortex, we just set blade vortex slot to the slot relative to the skill. That slot means the first slot, the first time it's been seen in your skill bar. So basically that means that when we click the start button, the bot will check all our skill in the skill bar, and if he found blade vortex, it will set blade vortex slot exactly to that slot. That means a number, for example slot 1, 2, 3, 4, 5, etc, etc. So we know how this blade vortex slot is created. Get back to our logic. So let's suppose that we have the blade vortex slotted somewhere, and now let's say in the slot number 4, that is usually the QK. So the blade vortex slot is now number 4, and it's not -1, and so we go on and check. Basically we want to check how many blade vortex charges we have actually on our guy, and how you can do that. Basically since some patch it was different before, but since some patch they do it this way. You have this property aureas, me, Lokipo, me represent you and all the information about you, and about you know your aureas, that are all the buff and the buff that you have on yourself. And it will find all, that it's a link you operation that will basically go through all the items in the aurea, that it can see it's a list. Find all will go through all of them and basically return a list of positive results. That means that for every single entry check if the internal name is equal to this one, that it's the name of the spinning blade, of a single spinning blade. And basically find all create a list of true value. So value that has this internal name equal to new blade vortex. And then it count them. And from if you have a list and invoke count, you get an integer and the counter of how many items are on the list. And then we have how many actual charges we have. And that's the number of spinning blades around us. So we do this. If this number of spinning blades is under the max blade vortex charge, probably we need to do something. And then we do another check. We check if is casting blade vortex. What that? That, well, a flag that we need because of this strange logic. We want to cast when under min value and stop cast only if we are above max charge. So we need to know the previous state. So what I did is, let's take a look. Basically, I created a general flag called is casting blade vortex, and initially it's set to false. So the first time this logic run, it's going to be false. So this is false. Now we check if the actual charge, and this is false. So we use the OR operator because we want to go inside this branch, go inside this logic if one of these two states are true, not both of them, just one, or this or this. So this is false. Let's check the other one. This is the first time this logic is running. So the actual charge is 0. Is it under min blade vortex change configured? 0. And we want, for example, have to at least 5 charges. So this is true, and this logic will trigger. So we now set is casting blade vortex to true, because now we are probably going to cast it, and we want to make sure that the next loop it's informed that we were casting blade vortex because we felt below the minimum amount. We want to get some information about it, and so we call this function. Basically, from the skill barcode we get slots with a slot number, and it will return us the skill in that slot. So now skill, it's since we know that blade vortex it's in the 4th slot, it will return us the skill in the 4th skill bar slot. Sorry if I'm a little bit confusing, but now basically skill contain the blade vortex skill information, and we check if we can use this is a wrapper function inside the DPB API that does a lot of different check based on the various type of skill, and return if the skill can actually be used. It's ready to cast, and if it is, then we go on and basically use it. And you can do that by calling this function LokiPOA in-game state skill barcode use, and this basically trigger a skill. It press a button or press a mouse button or whatever. There are many different type of use. For example, there is use hat that basically use it on a specific position, so you also move the mouse on that position before to activating the skill. Or use on, you can pass directly an object and try to position the mouse over that object, make sure that the object can be highlighted, and then use the skill. And then there is this begin use that basically click a button or hit a key and keep it pressed. I'm not going to explain begin use now because it can be a little bit confusing, so just for now ignore it. It can be used, for example, for channeling skill, where you probably cast them faster if you keep the button pressed. It needs a little bit of extra logic. Eventually I will show you. Send me a PM if you need some information about it. So we want just to press the button, not moving the mouse, not doing anything else. So we just do this use, and we pass him the slot. Use take these parameters. Int slot, and mean which slot this skill we want to use is slotted, and then it take a bool in place. If we want to press the key to cast a skill in place, the game allows you to do that, but well, we don't want in this case. There is also an extra parameters that you can send, that it's clear k. I want to make sure you know that this will basically clear all the k state before to press the button, and that has to be really think, because in case we are casting some instant skill, we are sure that we don't want to clear the keys. In this case, I simply don't care, so I just use these two parameters, and this will simply click the Q button or whatever is bound your slot for to. Then what we do is call a small sleep. Always use a wait coroutine sleep if you want to sleep inside async task. It's really important. We will avoid to lock the interface, and then we check the result of the use. If error 1, that is the return of the use function, it's equal to none, it means it has no error, then we will just return provided. That again will give control back to the combat task that invoked the combat routine logic, and will inform him that we have performed some action, and force the task manager to start again from the beginning. Task manager will run again and will eventually get back to the combat task, and the combat task again will get back here in the same state. We still have a target, and we already handled with Shrine, and again we have Blade Vortex, yes, and the actual charge are 1, we casted it once, and so we check if the actual charge is below max value. Yes, of course they are, and now we set the is casting Blade Vortex to true. So it's already one of the two are true, and we go on, because now we don't care about the min Blade Vortex change. The logic we want to run will need, since we started to cast it because we were below the min charge, we want to reach the max charge before to stop casting, and so is casting now is true, and we'll go on and perform the logical again, basically cast it and return provided again, and this will do it till we reach max charge. The moment in which actual charge it's above max charge or equal to max charge, this logic will not be performed, and we will go on, and we'll go on, and going on we will set is casting Blade Vortex to false, and then go on and perform all the other logic. And whatever happens, the next time we get here, probably we will have a number of actual charge below max value. For example, if we casted 10 Blade Vortex, now maybe we have 9, but now is casting Blade Vortex is false, and we are not below the minimum charges, and so we ignore this logic and we go on, and so this block of code will not be performed, and it will go on, perform all the other routine logic, and eventually end up using one of the configured skill on your configuration. In this case, if the only skill you are using is Blade Vortex, you can safely set just one of the two setting, one of the 4 setting to Blade Vortex skill. And what will happen is that we will go into melee range. It's a melee skill, yep. So it will get into melee range with the actual target and keep spamming Blade Vortex. Maybe you have some other skill, but well, for now what we care, it's about Blade Vortex. Okay, this is how you modify the routine. There is a lot of things you can do with that. What I show you, it's just some logic that it's performed by the routine every time we have a target. If, for example, you wanted to perform this logic whenever, that means even if we don't have a target. Now I know it's not super logic to do that with the Blade Vortex, but let me just show you. If this code, instead of being here, were here, for example, before the combat update, at the beginning, for example, this logic would have been performed every time the combat routine is invoked, and that means every time the task call the combat task. That means that basically you will keep always a number of charge between min and max amount, regardless if you have a target or not. That's obviously not perfect solution, but there are some cases where you want to keep your skill always up, whatever happen. So just moving the logic around in the right place will allow you to do different things with the combat routine. Okay, I don't want this video to be too long, so I will just stop it. Finally, we did a lot of change to our routine, and we want to make sure that it has a proper name. So it's different than all the other routine. Maybe you're creating some special routine. How can we do that? First of all, let's take a look. We changed the name of the solution. It's now called ExampleRoutine _BV mode. But we imported some old files. So the namespace complain that it's not exactly the namespace of this project. How can we solve it? Visual Studio came in our help, suggesting us to move it to the exact namespace. And that's one of the suggested solutions. Something else really important to do is this. Since you changed the name of the project, you don't want probably to have two routines with the same name in the DBB setting, and so it's quite important to also change the name of the routine. So it's an example routine with Blade Vortex support. Now we need to do the same thing to all the other file, ExampleRoutine settings. Still complaining. and so let's fix it. Probably we need to do the same even for the user interface and the .cs file in the user interface, this one. So let's begin from this and get back to the user interface itself. But look, we changed the ExampleRoutine CS file, and it automatically updated the routine name, the user interface name. So we should be safe now. If we try to compile it, compile successful. So let's now copy our file back to DPB. To do this fast, we just right click, open project folder, and DPB folder, the one from where we imported the file. So now we want to create a new folder, give it the name of the new routine, underscore bv mode, and add all the files. The only files that we need is ExampleRoutine.cs, setting.cs. I usually also add these two, Xalm and Xalm.cs, in case someone wants to modify the project, but they are not really needed because the Roslyn will build the interface using the Balm and the .cs, GCS. So we just copy all the 4 files, and then we need the Balm and the .gcs. So they are created when you compile the solution, and they are placed in the object folder, debug, because in this case I compiled it in debug mode, and here they are, .balm, .gcs. We take both of them and copy here in this folder. Now there is one last step that we need to do, and is this one. Since we created a new folder, a new project, we need to create the third-party JSON file that the Roslyn compiler will use, that DPB will use to create the list of file to compile. And to do so, you go to the main folder of DPB, find this file here, third-party config maker, run it, load a folder, and browse to your third-party ExampleRoutine, Blade Vortex mode, and just select one of them. Yeah, I usually select the main.cs and open it. And the third-party config maker will automatically create the list of all the files in that folder. And you click save, and what it does is it creates the third-party JSON for you, and that's it. In case you use references to DLL, external DLL, or dependency to other component in the bot. That's a little complex topic. I don't want to speak about it now, but I just mentioned that, for example, all those people that are trying to import the old default folder will probably add references to extensions. Those that are trying to do that know exactly what I mean. Okay, and then you just click save and close. And that's it. Let's try it. I have my client already running on the other window, and so we just run DPB as administrator. Give it time to load up. And open the setting, open routine, and now look, we have this ExampleRoutine Blade Vortex mode with our setting and obviously our logic. And the next time that you will run the routine, if you have Blade Vortex slotted on your skill bar, it will try to use it. And that's it. So, thank you for watching, and see you to the next tutorial. Alcor out.